Okay, so we are live. So we're going to talk about graphing exponential equations. Y is equal to 3 to the x. All exponential equations have the x as the exponent, right? So that's a major difference from all the other equations that we've seen so far, right? Major difference. And it makes a big difference in when you graph them and the kind of graph you get. We talked about it yesterday. You get the exponential graph, either a decreasing or a decay graph, or an increasing, like that, something like that. So when you do these, like I've taught you a lot of shortcuts, right? I've taught you shortcuts for slope-intercept, and shortcuts, for standard form, and shortcuts for point slope. But what if you can't remember the shortcut? What method would you use?
Well, it depends on the problem, but most of them work with T-chart equations.
T-charts, that's exactly right. So with these, use a T-chart. It works for everything, right?
Yeah.
So you're going to use a T-chart. So immediately I've got x and y. Now,
make them 0, 0.
Now, I am going to always want to include 0 as one of my x's, because anything raised to the 0 power is what? 1. So that's really easy, but I'm going to put it in the middle here. I'm going to make my x, 0 in the middle. So I know that's going to be 1,
but
right?
Even if you
3 to the 0 is 1.
You also, even if you forget, like if you completely forget to do the 0, 0 method, you can also, since you see that y equals, you can make x 1, 2, 3, and then you can see, plug them all in and see the
Yes, except that I'm going to recommend that you always have positive and negative numbers for your x, okay? Why would you think that? Why would that be important? Does anybody know?
Maybe to make it so that you get a wide range, because also
You would get a wide range.
Because there's positive and negative points on the graph. Not
So when I use a negative for an exponent, a negative number for an exponent, it's going to be, is it going to be a negative number? I mean, is the outcome going to be negative? No. It's just going to be a fraction. Negative exponents means tiny numbers, right? It doesn't mean negative numbers, it means tiny. So it's a fraction. So here we go. So we're going to, let's make negative 1 and negative 2 and positive 1 and positive 2. All right? Does that make sense? It's only 5. Right? It's only 5, and we already did one of them because it was so easy. So it's just 4, right? Okay? I can't believe I'm going to check this, but I'm going to check this. Oh, Albuquerque. I hope they leave a message. I need to talk to them. Okay. Okay. Here we go. When x is negative 2, 3 to the negative 2. 3 to the negative 2. How do I write that without a negative exponent?
1 over 3 squared.
It's 1 over 3 squared, which is 1/9. Okay, so I'm going to put 1/9 here. Okay, does that make sense?
I know. Yep.
Think about it. When x is negative 2, it's 3 to the negative 2. It's 1, and that's got to go downstairs. The base, right? The base is 3. The exponent is negative 2. So that's got to go downstairs. I keep a 1 upstairs, right? And now it's 1 over 3 squared, which is equal to 1/9, right? Okay? And then when it's x is negative 1, it's going to be 3 to the negative 1, which is 1 over 3 to the positive 1, or 1/3. Okay? And then when it's 1, 3 to the 1 is
and
just 3.
And it's just basically the same thing, just
and then 3 squared is 3 times 3 is 9, right? You'll notice that these numbers will be the same, except that one's in a fraction and one's in the denominator and one's technically
So
just
would it work out every time if you found the positive numbers first and then you just put a 1 over them and put them up for the negative?
Yeah, that would probably work.
Probably. That's an interesting.
As long as you kept the x's the same. As long as you kept the x the same, yeah.
As long as the numbers themselves are the same, it's just one's positive, one's
But
negative.
how do you? Oh, so would you? For one, let's say that like if you had 1 third and 3, right? Would you combine that together, start at positive 3, and then slope it?
I'm lost. Where are you?
So at the T-chart,
yeah.
Let's say that you took negative 1 and 1's answer,
right?
And then you said, okay, I'm going to start at positive 3 on the y-intercept, and I'm going to slope 1/3. Would you get your answer?
No, because it's not a consistent slope.
Your line
This is not a straight line where you have a consistent slope. It's a curved line. So that actually, think about it. That's a great question. It's a great question, but look at this for a second. If I have an exponential growth curve like this, the way you determine a slope is you have a tangent line. Do you guys know what a tangent line is? Like if you have a circle, right? A tangent line is a line that touches the circle. It's a straight line that touches the circle. And it touches in one spot. Does that make sense?
Yeah.
So, and that line has a slope. You agree with me? It might, whatever the rise is over the run. You follow me? But what about here? If it was touching here, it would be a line like this. So now suddenly it's this rise and this run. Does that make sense? And then if it was, you follow me? So it's like every single point is going to have a different slope. The same thing is true with a exponential curve, because it's always changing slightly, always, every moment, right? So the slope is totally changing, so you can't do it that way. So what you have to do is you have to actually, these are points, these are coordinate points. You go to the left 2 and you rise 1/9. You go to the left 1 and you rise 1/3. So if I was going to graph it, here we go.
Oh, no.
So here's 1, 2, -1, -2, -3, and 4. 1, 2, 3, 4, then 1. Okay, here we go. -2. So I'm going to go to the left 2, and then I go up 1/2, 1/9. So Logan, you take your notes. Up 1/9. 1/9 is very far, not very far. It's right there, right? Now -1, 1/3. 1/3 is just a little higher. And then at 0, when x is 0, it's at 1. And when x is 1, it's at 3. 1, 2, 3, 1, 3. And when it's 2, it's 9. 4, 5, 6, 7, 8, 9. So 2, 9. So there's my curve. Will it ever go across the x-axis?
No.
It will never go below the x-axis. Will it ever touch the x-axis?
Yes.
Yes.
No.
No, it won't, because it never goes. It never gets to 0.
Oh yeah.
I mean,
you can go
it's
super
that
small,
little
but it
dilemma.
won't.
It's that little dilemma. If I'm standing here between here and the wall, if every step I take is 1/2 the distance from where I am to the wall, will I ever touch the wall? No, because I will always only be going 1/2 of the distance between where I am and the wall. Does that make sense? I know, it's a little bit of a dilemma. Like it's like your brain starts to say, well, eventually you're going to run out of space.
One
right?
easy way to explain, it's called Zeno's problem, and it's a Greek mathematician.
Well, do it over here.
Okay.
Do it on this.
And so basically, yeah, the thing is that like if a man wants to get to a park, this is the distance. First he'll have to get halfway, and then he'll have to get halfway from there, then he'll have to get halfway from there, over and over. But an easy way to picture it is you get halfway, and you get halfway again, but you still stay within the same perimeter. So it wouldn't take you infinitely long. It would just, yeah, because you stay within the same amount of space. So even though, yeah, the distance does get smaller, you still will get there. It's not like you're going to take an infinite amount of time.
But in this case, it will.
But in this case, it will. It will never cross the x-axis, and it will
Yeah,
never touch the x-axis.
Well, yeah,
right?
in this particular problem.
Yeah, right, right.
The walking.
So does that make sense? Do you guys see that?
Yeah.
So it's really straightforward. As long as you understand how to deal with the negative exponent, right? Okay. So now let's look at this one, because this one is significantly different, even though it looks almost identical. You see that? Notice on this, all my x's, whether they're negative or positive, all my y's are positive. Always, all of them are positive. On this one, all my y's are going to be negative. All of them.
So this is going to be a
Right?
decay one?
So let's do it. Let's do it.
This is going to be exponential decay, right?
So here we've got, yes, it probably will be. So we'll see. We'll see. We've got, what am I doing? T-chart, right? So we've got x and y, and I know I'm going to always have 0, right? And I'm going to do a -1 and a -2, and I'm going to do a 1 and a 2. Okay? So -3 to the -2. What is the exponent effect?
What is next to?
It only affects what it's next to. What is it next to? It's only next to the 3. It is not next to the negative. So nothing is going to affect that negative. That negative is always going to be there. Does that make sense? So your answer and for y will always be negative. So immediately I'm going to put a negative here. And then I'm thinking, oh, what is 3 to the negative 2? Well, it's 1 over 3 squared, which is 1/9. So it's negative 1/9.
It's just a negative.
Right? So, and then this one's going to be negative. So negative 3 to the negative 1 is negative 1/3, right? Negative 1/3. And anything to the 0 power is 1, but it's going to be negative 1, right? It's going to have to be negative 1. Negative 1. So 3 to the 0 is 1, so it's negative 1. So suddenly that's negative 1. And then 3 to the 1 is 3, so it's negative 3 and negative 9. Does that make sense? You see it? Yes. Wait till the last one, because I'm almost done, right? So really fast, if I graphed it, where are we? So 1, 2. Okay, so it'd be negative 2, negative 1/9, right there. Negative 1, negative 1/3, right there. 0, negative 1. What is it? Where am I? 1, negative 3. 2, negative 9. So here's my graph. Right? Right? All right, so now, last one, this one. Want to be sure you guys know how to do them when they're fractions. Can I erase this?
Yes.
Yep.
Can I erase this?
Yeah.
Yes.
Okay. I will just work over here. Can I erase this right here?
Yeah.
Okay. X, Y. So, again, I'm always going to have a 0, right? I'm always going to probably do a negative 1 and a negative 2. Okay? And I'll probably do a 1 and a 2 here. All right, let's try to figure this out. What is 1/3 to the negative 2?
Well,
Negative 2 over.
Wait.
no, it's
A negative exponent does not mean it's going to be a negative value.
It's wait.
It means it's going to be a tiny value, right? However,
It's already a fraction. Wait, hang on.
However, it's technically the opposite.
It's also
sign.
it's also in parentheses.
Since you flip it,
Yes.
it's
Yeah.
going to become negative, so it's just going to be 9.
Negative.
So if we did it the long way, this would be 1 to the negative 2 over 3 to the negative 2. You agree with me?
Yes.
Which is really, flip it,
3
you
over
have
1.
9, 3 to the positive 2, which is 9, or over 1 to the positive 2, which is 1, which is just 9.
Yeah.
Does that make sense?
Yeah.
Does that make sense? Do you guys see that?
9, 3, 1.
Right? But now, let me just show you a trick. When you have a negative exponent, any fraction raised to the negative exponent is the same as the reciprocal of the fraction raised to the positive exponent.
So basically, in this case, it'll be reversed.
So it's 9. Yeah,
It'll
exactly.
be the reverse
Exactly.
we did before. So
Right. Right? So technically, so what is 1/3 to the negative 1 is 3 over 1 to the positive 1, which is 3. Yes? Am I losing people?
no.
Okay. 0. Anything to the 0 power is 1. That one's so easy, right? 1/3 to the first power? 1/3. 1/3 to the second power? 1/9. Right? Right? And so then, when you graph it,
But how do you graph 1/3?
well, I've been doing it all these times.
Yeah.
I've been graphing 1/9 and 1/3, right?
You
Well,
just do the
but
reciprocal.
now watch.
Oh.
Watch when I do it. So negative 2, 9, okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's negative 1, negative 2. Okay, here we go. Negative 2, so Basie, watch. Negative 2, 9, boom. Right? Negative 1, 3, boom. And then 0, 1, and then 1, 1/3. 1/3 is about there, right? And then 2, 1/9 is just above that line. With me?
So all these.
Because this is 1, so that's got to be a 9th of 1. You just it's you're guesstimating kind of where it's going to go. But here's my graph. And it never touches that x-axis.
Except it does.
Except it does. Right? All right, fist of 5. Does it make sense?
Yes.
It's really not that hard. It's a little tricky. Certain parts are tricky. And so if you're confused on something, ask me or ask one of your classmates, okay? I'm going to be focusing a little bit on that other group that was gone yesterday. All right, any questions before I end this? Questions? Which part are you lost? Just give me an idea of where you're lost. James, which part? Do you understand how I got that? Were you lost in these two or just this one? Mostly this one?
Or all of them.
Okay, that's okay. Well, I'll come help you. Okay. All right, so I think I'm going to end the lecture, okay?